Hello. Today we look at solve equation from graph of roots. So what we do, we select level 1. So which choice could represent the graph shown below? What we need to keep track of are the roots. Roots where function cross x-axis, where value equals 0. So we have root at x equal -1, meaning we have factor of x plus 1. Because -1 plus 1 is equal to 0. And that's what we see here. Here, we similarly have a root at x equals -2 because x minus 2 must be, x plus 2 must be 0 when x equals -2. So we want x plus 1 and x plus 2 to be the roots, or the factors that go into this expression. That will show us how to get this lovely graph. So we'll go to another problem just for the same thing. I'm actually going to do a new problem because I want to do one that gets all squiggly. There we go. For this one, it bounces, meaning at the point where it bounces off the x-axis, we know that that root has an even multiplicity, which is a fancy way of saying it happens an even number of times with that factor. So, for example, instead of having an x minus 2 corresponding to this, we would have an x minus 2 squared because we need to repeat the root in order to actually obtain that part on the graph. Here, the x equals -7 being a root only needs to be here once because it crosses through, or more specifically, an odd number of times. However, we're going to be satisfied with just seeing it the once. So it's a relatively straightforward thing that we're asking you to do. So here, which equation choice could represent the graph shown below? Anytime we have an even multiplicity, that means we got to bounce off the axis. Every time we got an odd multiplicity, we cross through. Meaning if something only shows up once in these problems, then you know that it's going to cross the axis at that point. And if it shows up twice, then it means it's going to bounce. So here we know it bounces. When x equals -5, it's going to bounce off the axis here. So would that be it because we have a -5 right here? No, you have already thought too far ahead. Because when x equals -5, x minus 5 won't be 0. That'll be -5 minus 5, which is going to be -10. So we need that factor to be x plus 5. But is that going to do the trick? It looks like this is only happening once, which we know is not good enough because it needs to bounce. And that needs to be the guy that happens twice. So we know x plus 5 happens twice. X minus 7 is fine to just happen once because we need it to cross instead of bounce. There's not really terribly a lot to explain. Just happens more than once, or happens an even number of times, it bounces. Happens an odd number of times, it crosses. So bounce at -5, cross at -1, plus 5 happens twice, plus 1 happens once. Let's move forward and do the right polynomial function from graph. So here, write a function in any form that would match the graph shown below. Now we're going to have to write this. So we know that this has a root at x equals -3. So we need an x minus 3 somehow or other. Good. But does it cross or bounce? Well, y'all are Dora the Explorer figuring these things out. I'm going to just tell you it bounces. So that's going to have to happen an even number of times. I'm just going to call it 2 for now. We'll see if we need to adjust. Here, it's crossing at x equals 2. So x minus 2 needs to be a root. And I made a typo on the one on the left because at -3 is our root, meaning x plus 3 has to be our factor. So that needs to be what we do. Now we actually have to check and multiply it out to make sure that at 0 we get -12. So if x is 0, then that's just 3 squared times -2, which is 9 times negative 2, which is negative 18. So that is actually not going to be correct just yet. What we're going to have to do is multiply that by 2/3 in order to actually make it equal negative 12. So you've got to find the roots by plugging in your polynomial that way, and you find the intercept on the y-axis by adding in a coefficient to the whole deal. So we have that a value thing. Full function is this guy. Found the intercept. We know that f of 0 is negative 12. That gave us 9 times negative 2. That was negative 18. That means we just solve for a, plug in 2/3. We'll do one more of these, and then I'll turn you loose. Not hold you too long here. Okay, what bounces? Negative 2 bounces. You're correct, kids. So what happens when it bounces? X something 2. It happens an even number of times because it bounces. And we got another one at x plus 1, or sorry, at um, x equals 1. So x something 1 needs to be a root. Your job is to figure out the plus and minus. And by your job, I mean whenever it's your turn to actually work this delta assignment. For me, I will show you that it is x minus 1 because the 1 is a positive root, and x plus 2 because the 2 is a negative root. We need that to equal 6 when x equals 0. So when x is 0, x plus 2 is 2. You square that and you get 4. You multiply by x minus 1, which is negative 1, and you get negative 4. In order to get an a value, we need negative 4 times a equals 6. So the only way to get that is negative 3 over 2. So that should cut the 4 in half, make it positive, double negative, and turn it into a 6. Look, y'all, do your best here. If y'all have questions, ask me or ask Crawford, and we'll be more than happy to help you. In the meantime, have fun doing this Delta assignment.